In this video, we are going to find AND behavior using limit notation. So let's take a look at AND behavior. What is AND? Which AND? What AND we are talking about is. So the AND behavior of the graph of the function describe what happens to the function value. Value means y. What happens to the function values on the extreme left and right end of the graph. Okay, so this is the xy coordinate. X goes to infinity. What's happening to my y value? X goes to negative infinity. What's happening to the y value? Is it leveling off somewhere? Is it going to infinity? It is going to negative infinity. So that's what we call AND behavior. And we have to use the limit notation. Now, one possible AND behavior is called the horizontal asymptote. Possible that the graph levels off at somewhere. So horizontal asymptote is actually one kind of AND behavior. There are two ends, left and right. Left end is negative infinity, right end is positive infinity. Now, not all the functions goes towards both ends. Some functions go only in the one end towards the one direction, and then there is only one end behavior. Let's talk about how do we write limit x approaches negative infinity. So instead of infinity, this says decreases without bound. Decreases without bound means going towards negative infinity. Increases without bound, that means going towards positive infinity. This is also called limit at infinity. Limits at infinity, again, going to positive, negative infinity. If it labels off at some number L, then we say that that's the L. In other words, this is a horizontal asymptote at y equal to L. Not every function has a horizontal asymptote. Some functions don't have any asymptote. We are going to look at some examples here. Understand, we don't have to know what's happening in the middle. We only need to know the end behavior. Also, you are not expected to sketch the graph. You are only expected to know what is happening at the extreme end. And you have to use the limit notation. So this function I'm going to explain different way here. 3x divided by x square plus 1. Now x goes to infinity. Where y is going. This is what you used to write in algebra 2. X goes to infinity. What's y? X goes to negative infinity. What is y going to be? Difference here is in pre-calculus we have to use the limit notation. So let's understand first of all how do we write the limit notation. So I'm just preparing the format. X approaches negative infinity where f of x going, and limit x approaches positive infinity where f of x going. We need to get these two answers. Let's check here. X is very large number, and dividing by that very large number you are squaring. Adding 1 is not going to make a difference. So when x is going towards infinity or negative infinity, you only look at the leading terms. So if you simplify this, 3x over x square, that becomes 3 over x, which is the same as 1 over x. So you are expected to know what is 1 over x look like. 1 over x is rational function, and we can see that when x goes to infinity, y becomes 0. X goes to negative infinity, y becomes 0. In other words, these two numbers are 0. We can also call that this is a bottom heavy function because the degree of denominator is bigger than degree of numerator. And if you identify the bottom heavy functions, you don't have to do any of this work. You can straight away write down that there is a horizontal asymptote at y equal to 0, which means these two limits are 0. What this means is, again, the graph levels off at x goes to infinity, y goes to x goes to negative infinity and infinity, y value will be 0. This is using limit notation. So let's take a look at a couple of more examples here. F of x equal to 4x cube. This is not a rational function. X cube. This is a little bit easier. X cube looks like this. You don't have to sketch the graph, but you should know that cubic functions are increasing without bound, decreasing without bound. How do we write the limit statement? Limit x goes to infinity, f of x increases without bound. Positive number increases to positive number, negative numbers to the third power is negative, which means negative infinity. So this is in algebra 2, you used to write as x goes to infinity, y goes to infinity, x goes to negative infinity, y negative infinity. This is algebra 2 answers. This is honors pre-calculus way to write the end behavior. Let's take a look at one more example here. Another rational function. Well, 4x square over x square plus 1. So just ignore the 1. Let's get the format ready. X goes to infinity. F of x comes here. You don't write the whole limit part. You have to show the arrow. Limit x goes to negative infinity, f of x. Okay, so now let's check it out. When x is very, very large, you just ignore the numbers. You only look at the leading terms. What is 4x square over x square? X is very, very large. You are squaring this to get cancelled. Answer is a 4. Which means what this means is also horizontal asymptote at y equal to 4. We can say that this is the degree of numerator and degree of denominator is the same. When they have a same degree, you only look at the leading coefficient 4 over 1. That's why horizontal asymptote at 4. So this is called asymptote. Same answer. This is called end behavior. The same, different way to describe. Here I'm going to use a couple of more examples to explain the end behavior. So what happened if function has only one end, ln of x, let's say. So here we know that the log of negative number is not defined. So this function, there is only one end. X approaches infinity. Function is going to infinity. Only one end. Because of the domain. Domain is never negative number. Domain is always x is greater than 0. So x is never ever going to go to the negative infinity. That's why we have only one end behavior. Okay, I would like to include another example which has only one end behavior is f of x is equal to, let's say, square root x plus 2. You know that square root functions are going only in one directions. Function is not defined for the negative numbers. That's why it has only one end behavior. Answer will be the same as this. Okay, so I'm using another function, exponential function. E to the x. And let's say plus 2. Okay, so what would be the end behavior? So x approaches very, very large number, e to the infinity. It goes to infinity. And then you add 2, infinity plus 2 is not making any big difference. So we can say that limit x goes to infinity, g of x going to infinity, because e to the infinity is e to the very, very large number is again another very, very large number. Adding 2 is not making a difference. So that means x approaches infinity is infinity. Limit x goes to negative infinity. Well, e to the negative value, which will be, think of that very, very large number, e to the negative, very, very large number, and you are adding 2. So this is basically 0 because negative number, you are raising to the negative number, which makes it 1 over negative number, I mean 1 over that number, which is very small, and you are adding 2, so that will be 2. Another way to check is you can see that e to the x is shifted 2 units up, and that is the graph. So you can confirm that x approaches infinity, goes to infinity, x approaches negative infinity, it is 2. So make sure you understand the end behavior of every function. This is a very important concept. You have to visualize where the graph is heading in each direction. Thank you.